Last time we talked about mathematical models. So why do we have mathematical models? Sometimes it's impractical to build a model of the weather, for instance, or sometimes it's not cost effective to build a model to test in all the different conditions you might be interested in. So we try to build up mathematical models that will allow us to go through different scenarios and make predictions about what may change and when may it change. When constructing mathematical models, there's certain steps you have to do. You have to identify the problem. What are you trying to make a model of? Then you have to make some assumptions. Many of you have used to making assumptions. Things like no air resistance. The temperature is constant. There's no wind. Depending upon what you're doing, all kinds of assumptions that may be made. And then identify and classify the variables involved, determine the interrelationships among the variables and the submodels. As you build a more complicated model, you may have a submodel for one aspect of it, and then you're trying to build upon that. Then since we're dealing with mathematical models, we're really meaning equations, at least oftentimes. And so then we're interested in solving those equations and therefore solving the model or interpreting the model. And then we compare the results from our solution mathematically with the results from, quote, real life to see how accurate that model is. Sometimes we need to simplify a model so we can actually solve it. We restrict the problem. We may neglect variables. For instance, we might neglect the barometric pressure. We might set some variables to be constant. We might assume the temperature is constant. We might assume there's linear relationships. Of course, about any of all those assumptions, you make the model simpler, and therefore it's easier to solve. The downside is it may be less accurate. The predictions may not be as good. So then there's ways of refining that model. You expand the problem. You consider more variables. You allow variation in the variables. You consider nonlinear relationships. By doing so, you make the problem more complicated. But if you can then solve it, you can then hopefully have better and more accurate results and predictions.